Now it's seen as Rob and Adam are pinned, right?
Sorry?
Now you can see that Rob and Adam are
Yeah,
pinned.
yeah.
All right, then let's not wait further, because I'm sure this is a very interesting topic and we have the ambition of keeping it to an hour. So let's see how that goes. As I said, welcome everyone. This is the last session of our Protein Engineering Festival during the month of April. Maybe some of you already joined to one of the sessions where more even maybe scientific topics were discussed. And normally in the lab we focus on sequencing, structures, and folding. But then in the real world, bringing a designer protein to market requires a different kind of architecture, which is the intellectual property. And this is where the topic of why we are here today. And we want to talk a bit about this black box that for most of scientists is the patent process. And for that, we have two incredible experts. We have Dr. Robert Cogger-Ward, sorry if I mispronounce it, who holds a PhD in molecular microbiology from the University of Nottingham and is an associate in the biotechnology team at Potter Clarkson. He works on protecting and developing intellectual property across the life science sector, supporting organizations in translating science innovation into commercially available, valuable assets. And if you want to add anything to this, Rob, feel free.
That sounds like a great introduction to me. Thank you.
Amazing. And next to Rob, we also have Dr. Adam Sweetlove. Oh God, I'm so sorry for my pronunciation. Who completed his PhD in biochemistry at the University College London and followed a career in industry. He is now a technology transfer manager at École Polytechnique Fédérale de Lausanne, and he operates at the intersection of research, intellectual property, and commercialization, helping researchers bridge the gap between the bench and the boardroom. Welcome, Adam.
Thank you.
All right, so let's first start with rather philosophical question, I would say, because in the world of protein engineering, we often heard that you cannot patent nature. And of course, if I engineer a more stable version of an existing enzyme, where does the nature and where does the invention begins? And maybe Rob can start with this question.
Yeah, sure. So we'll give a very loyal answer to that question and say that it depends. So patent rights, they're territorial rights with like country-specific laws that govern what they can cover. Lots of people think that you can't protect natural things. That's not actually true everywhere. And I think that perception comes from like a very US-based kind of US-dominated thinking. So it's true that in the US you can't protect natural things full stop. But in Europe and other sort of slightly more liberal territories, it's possible to have a patent claim that's directed to a natural protein if it's an isolated protein, so that the claim doesn't cover it in nature, but it covers it in an isolated form. Now, whether that kind of claim would get granted depends on whether it's new and inventive, and that's kind of where the real challenge in Europe and other similar territories lies, in getting things granted rather than it being the subject matter per se that you can't protect. Getting protection gets a lot easier if you're using that isolated protein in like a new method or a new use, or expressing it from a bacteria as part of a new expression system. That kind of thing can help protect natural things which are protectable in Europe. Other things that you can do to make it easier, and kind of where nature ends, to go back to your question, is to kind of go away and start engineering your protein. And in that case, like one non-natural mutation in your protein can make it not a law of nature, it can make it novel. And if it gives you a surprising technical effect or improved characteristics compared to that original version of the protein, it could be inventive. And basically, the more mutations you make, the more arguable it is that your protein is non-natural, new, and inventive, and the easier it gets for you to be able to protect your protein.
Nice, thank you. Yeah, as I say, it was a bit rather more of a philosophical question. Do you have anything to add, Adam?
Yeah. I mean, it's philosophical and not, because research basically, you're transforming discovery into something, technical. And that's the way in terms of technology transfer. That's what you do. And in a way, it's interesting, Rob, that you mentioned the US, because the US, it boomed. The law. Again, Rob explained patents is territorial nature, and the law varies, it changes, and it happens in Europe. It's been fairly consistent since well, I won't get into history, but since at least the European Patent Convention. But in the US, the 80s, you could patent more or less anything, and there was a famous quote from a Supreme Court case. It says you can patent anything under the sun. And at the time, you could, that allowed the biotech to boom, and you could take any genes, isolate them, and that combine natural things, and that was a manufacture. And then, around 2013, things changed dramatically. Again, the political mood. You probably heard the case of Myriad. It was a diagnostic company who was very aggressive had a gene patent for the BRCA. It's a cancer gene, and enforced it, against research institutions, against hospitals. It was very aggressive, and the court, then Supreme Court, reviewed, if you want, changed the dogma, the doctrine, and since then, it's and with other cases. In the US, it's been very difficult to protect natural, pure discoveries, pure things that exist in nature, etc. So it's always something to bear in mind when you patent, that the law can change, and different countries have different requirements. But other than that, I mean, you can transform. I mean, the point of the patent system is to protect something that's technical, but you can take something, so it avoids. If you're in Europe compared to the US, it's an inverse logic. In the US, it says you can protect this. It has to be a machine. It has to be a composition of matter. It has to be, there's 4 categories, and you fall into that, and then you can have a patent. Okay. In Europe, it's much more flexible. It's there's an invention, as long as you don't patent a discovery, a mathematical process, something completely abstract, a business, etc. Then that's an invention, but they don't define what's an invention. So anyway, so generally, a good discovery, you can often transform that into a good invention, but it has to be technical. That's kind of the.
So Adam, since you're mentioning this technical part, let's look at how you would patent a protein. And you mentioned together with Robert that if there is a mutation, or if it goes a bit further from what's there in nature, it's a bit easier. So let's assume that you have an engineered protein, either as a mix of natural domains or designed with machine learning methods, for example. What part of this engineered protein is protectable? The sequence itself, the design, like in the structure, or the methods for obtaining it, or even the training data if it's a machine learning designed protein. So which one of these, and Depending maybe on the kind of protein that you get, do you use different strategies choosing one component of the process or another? Adam, if you want to pick up from...
Oh, okay. I thought I was going to let the Rob. Sorry.
I can pick it up if you like.
Yeah. I mean, there's many layers in your questions. So, there's the basic composition of matter. That's the protein. As Rob said before, you put an artifact, something that doesn't exist in nature. You can patent that as long as you have novelty and inventor step. And maybe Rob, you can expand a bit on these criteria later, as they're important to understand patentability. But in terms of pure subject matter, these things don't exist in nature. So you can patent them, especially if there's an advantage and an application that you can find for them. Then there's the method of actually, which is interesting in your field. So you're using machine learning. So these they're more tricky because they're computer implemented, but certainly you can patent these if there's a practical application, if there's a lingering reality. There's ways of doing so. Purely in terms of be it in the US or in Europe, you can't just protect something abstract, an algorithm. It has to be put in Europe, they talk about technical effect. There has to be a technical effect. In the US, they say there has to be a practical application. But at the end, it boils to the same thing. And that's always something, it's not always easy to protect, but there can be value in that. And I think one of your questions has to do with the data, I think you meant. So the data per se, of course, you can't patent, but there's value depending, because especially, with the AI, obviously that's the fuel, if you want, that's going to allow you to train. So there's a lot of value there, but that would be more in terms of technical measures and using contract law to protect yourself. So it's a different ball. It's probably something either you use a trade secret or contracts. There's a lot of pressure in academia to share the data, especially in the research community. So it's very hard to say, oh, I'm going to keep everything under the hood, as you would if you're a company, which some companies can do that. But of course, it's you also want to drive the traction of the community, etc. But even at the research level, there's ways to share the data and make sure that you have commercial protection, so you can leverage the value on that. So I don't know if you want more on that, but it's just so it's possible.
Okay, thank you. It's very interesting, and it has indeed a lot of layers, as you said. Robert, would you like to add something on the patentability of the sequence, for example?
Yeah, sure. So I mean, all of those things, apart from, as Adam says, like the training data, can be patented and protected. Generally, like the strongest protection that we go for would be to the protein per se. So we would protect a protein with a given sequence. We might even try, if you have a mixture of known domains, not protecting all of those domains kind of spliced together, but we try and find the clever bit. So if you have 3 domains, but you only need domains 1 and 3 to get your technical effect that Adam was talking about, we try and draft quite broadly, and that protein claim would allow you to stop anybody from making, using, keeping, advertising, importing, and selling a protein that had domains 1 and 3, and that gives you like really powerful protection for a protein with that given sequence, basically in any use. We also try and cover like use cases. So if, for example, you have a new protein and it also has a medical use, we would have like a medical use claim or like a medical method claim in the patent. That's what we try to do. The design method is like a bit more borderline, and it basically depends on what you're doing and what you want to do with that design method. So if you want to license that method out to third parties, it's really good to have a patent with a claim that covers that design method, because then you A, have legal certainty about what you're licensing to them, and B, you can enforce your patent against them if they do things out of the scope of the license. If, however, you're just going to be doing like fee-for-service type stuff, if you're just going to be using the method in-house, you might want to keep it as a trade secret. And you probably don't have to disclose the way that you designed your protein in your patent application. You can keep it secret. What you want to do in your patent application is disclose the protein sequence, show the technical effect it has. How you actually arrived at it doesn't necessarily matter.
Thank you, Robert. Sophia, would you like to ask a question yourself now?
Actually, I was wanting to follow up a bit on what you were now discussing before we move to the next topic, which is also very interesting. But I was wondering, so I'm purely lab scientist, so I'm very far away from what you do, so probably my questions are quite naive. But I was wondering if you want to pattern a protein that you find for a specific function, but then in the future it is found that it can also do some other thing. Does it have to go through another application, or you pattern the protein itself and the future applications that is gonna come with it?
Yeah, so shall I take this one? So if you have a patent that covers the protein per se, then like that protein is protected, and anybody who for basically any use, because you've protected the protein itself. So anybody who uses it, sells it, makes it without your permission as a patentee is infringing your patent claim. That doesn't mean, however, that if you find a new use for it, you can't patent that, because the new use is new over the protein per se, and maybe you had a use for the protein in the original patent application. That's quite useful to know, because it allows you to, in some ways, extend the monopoly you have, or kind of grow the monopoly into potentially new areas. So that allows that gives you a business advantage, because you're kind of extending the monopoly that you have over the protein and over the use in new areas. And it's something that is quite common in pharmaceutical industry for people to patent a new indication for a known drug. I mean, like like Wegovy and things like that are a very good example of a drug that's been around for a very long time for use in diabetes, and now it has a completely new application that can be protected, and actually it turns out has even more economic value than its original medical indication.
Indeed, and even if but it has to be, this patency has to be applied from the same entity that applied for the first pattern, or it can also be a different entity?
No, not necessarily. So as soon as something's published and it's out in the world, you're free to do research on it. So yeah, if someone's published something in a paper, you're free to research that. You're free to research the subject matter of a patent application or a patent. That's a very narrow a very narrow kind of exemption to a patent infringement, and you are kind of allowed to innovate on top of patents. Where the line becomes a bit kind of blurry is like a patent is like a so-called negative right. So the holder of a patent is allowed to stop people from doing something. They need to make the conscious decision to stop somebody from doing something that falls within the scope of that patent. Generally, if it's a university that's working on something in research or R&D, it's quite bad press to sue a university. People tend not to do that. I mean, there are notable exceptions, but people tend not to do that. And what that means is that within university environments, people are innovating on top of patents all the time. And if you make a new invention that's based on somebody's patented invention, then that new invention is yours. You own it. The fact that someone already has a patent that covers like a part of your invention doesn't detract from the fact that you've made something new and you can protect that yourself.
Okay, thank you. It's a bit more clear, but I understand that it's probably very case specific every time that you need to do something regarding this. Now let's move a bit to something that has already been hinted in the conversation, and let's take the nice advantages that we have here. Rob that works more with the commercial applications, and Adam with the academic work, kind of. So yeah, we were wondering because, for instance, the EPFL is a powerhouse of research and scientists that live by publish and perish. So Adam, how do you help researchers share their science? Because we need to keep sharing our science, but without accidentally destroying patentability.
Yeah, no, it's a tricky balance because there's so maybe it's good to take a step back because we went deep in the in the subject matter. So to obtain a patent, again, it's very important to understand two things. It's a negative right. It doesn't give you a right to own or practice an invention. It only allows you to exclude. And that's often a typical mistake that a lot of people make. And the second aspect is the patentability criteria, which are very important. The first one is the novelty, which we discussed. I won't go deep into the novelty subtleties, but in Europe, it's and now in the US, it's and most jurisdictions actually, it's an absolute criteria. So it has to be new wherever in the world. So even if there's an obscure Chinese or Tibetan reference somewhere, it's prior art. Okay. And often our researchers get surprised and tricked by this because there's an obscure Chinese paper. That's why I was referring to China somewhere, and they weren't aware of it because obviously it wasn't into the radar and it was in somewhere in the patent literature, in fact, and this happens. So that's something to bear in mind. The criteria is absolute, and it's not whether someone would have that access, is whether they could. And so, even if there's a book or a thesis that's somewhere in the deepest library that nobody ever visits, well, it's just there. And it doesn't matter. It is prior art. So then, of course, at the level of maybe I won't go. I'll stop there because I don't want to confuse you. The next criteria that's very important is the inventive step. And this is typically it's whether there's an advance, a true advance, and not just a little bit of obvious developments. There's different tests. The European has an interesting test that's rather objective. it's criticized. I know the UK criticized the European test, but I won't get into that either. Maybe you can expand on that, Rob. I'll let you. And then the US has another one, but it's all about whether someone's skilled in the prior art. So in the technical field, looking at your invention and the prior art, and he's able to use his own general knowledge. So they call that the common general knowledge. Would he be able to combine some references, been cited to do so to get to your invention? Okay, so that's the obviousness criteria. And the other one that's super important is the sufficiency. So you're getting a patent application, well, patent, because at the end it's the patent that allows you to enforce your rights. A patent is a quid pro quo that society makes. What it says is, we're giving you a monopoly right against the fact that you're teaching the world how to make an invention. So rather than keeping things under the hood as a trade secret, you describe your invention, enabling skilled persons to make your invention, and then that's going to be the ambit of your monopoly. It's very important, and your invention is published after 18 months from filing. Okay, so the quid pro quo, you make available to the society your invention, so there can be a carry on of innovation, and people can actually improve it. And that's what you can have a use, second use applications. So that's or even a completely new improvement, new proteins. But it's very important to have this in mind. And so the enablement is often it's the two pitfalls in academia are the novelty, because the researchers have forgotten or are not aware of the absolute novelty criteria, and so they've put their paper on the archive or preprint, and then that's dead, or published a thesis and didn't actually realize, or put it on the internet, but the internet is accessible to the public, so bam. So these are pitfalls. And the other pitfall is sufficiency. Do you have enough results to have a meaningful claim that's broad enough commercially? And that's that. So these are the two elements which concern academia, where in industry they have this more under control, because obviously things are secret. No, you don't talk, you don't say anything to anyone until things are protected, and until we've got enough data. So this is the balance we have to work with in academia.
Yeah, that's quite interesting. So, but then I was wondering, because to this balance between this novelty and have enough sufficient data that back up your invention or your new thing. In your case, will researchers approach to you when they think they have something before publishing, or has it happened to you that they are too late? Like, yeah, this is too far out. We cannot do anything with it.
No, of course it has happened even at EPFL. Mm-hmm. The point is educating. So going around educating, making them aware. But of course, not every scientist, is interested in patenting or even in technology transfer. A lot of scientists are just interested in, doing their science and advancing it, which is fine. You do different things. Sometimes part of their career, they start realizing that actually through a patent, they can actually transfer where they've been their science and actually make something useful. When useful, it means actually with an application that can help. Useful is when you start usually making a product. Not always, but usually that's, and so it's translating it to the patient or whether. I mean, it's not. I mean, here we're more looking at the healthcare, but it can be broader than that, of course. So yeah, it's a lot of education at the end of the day. But honestly, there's been vast improvements compared to. It helps also because we're a technical university. So and there's another point. It's emulation. You see here, steadily the ecosystem has been growing, and there's more and more people having success. Startups being on the newspaper, having great inventions and papers with it, and it creates an example, and people talk, scientists talk, and
Yeah, they become more aware of this procedure.
yeah, it's raising awareness, exactly, education, awareness, emulation.
Yeah, definitely. Maybe now from a more commercial point of view, of course, this question goes more to Rob. How different is this strategy around disclosure or the timing? And yeah, is there is this tension in industry? I guess no, based on what Adam said. But could you develop a bit on that?
Yeah. So I think that universities and companies, they have very different goals. So in my experience working with university TTOs, the aim of the university is generally to license out their tech to a third party, which can be the academic that came up with the invention spinning out, or it can be anyone who's interested in licensing it. That means that universities are a lot more prone for going for like broader patent applications that have everything in them to maximize the scope of protection for the spin out, or to increase the chance of licensing it. Established companies, like, they generally have a very specific thing that they want to protect, and they draft applications around that. They try and keep know-how out of patent applications, whereas a university or an institute might just put it in because it's going to be published in a paper anyway. And generally companies try and keep their disclosure to like an absolute minimum. And that's to stop competitors and other third parties from easily figuring out what they're doing. And they're also more likely to keep that as a trade secret, because in a company, that trade secret has a lot of financial value. To a university, keeping something secret, there's no financial value because the university isn't exploiting it commercially, doesn't get any money from the government in the form of grants because it's keeping it secret. I think for both, though, the advice is basically the same. Don't disclose anything before you file a patent application, to keep that absolute novelty there. This can be a lot easier with companies that can be a lot more attuned to the IP requirements, and they don't have the pressure to publish things, other than for like, in press releases and submissions to regulators and things like that. There's not necessarily that much pressure on a company to keep something secret, to publish something and make it publicly known. All of that doesn't necessarily mean that you can't publish your work in academia. In fact, you can usually submit the manuscripts to a journal before you file an application, because there are confidentiality clauses in place with reviewers. But yeah, you need to be aware of the timeline and make sure you have something on file before it publishes. And that kind of cuts across academia and commerce, I think.
Thank you both. If I may, Sophia, I would like to pick up from something that Adam said that sounded very interesting. You mentioned, Adam, that sometimes scientists realize after some time that if they had patented one of their inventions, then that discovery could have had an application, a real concrete transition into something real, not just a discovery. And it's a bit counterintuitive, because on one hand, you're patenting it in that case, so you're blocking others from using it. But at the same time, I can imagine intuitively our patent can actually open some possibilities for creating something. So can you maybe go deeper into why a patent can promote application and concrete transition to something?
Yeah, for sure. So yes, a patent is to enforce. It gives you a monopoly right. Of course, it's very expensive to enforce. But it's also, I mean, we talked about licensing to start. So licensing means giving rights on the patent to a third party or a company. Typically, we do so big. It could be a big company. Often, a lot of the technologies go to startups, universities, just because a lot of the technologies are pioneering. The deep tech, and generally companies don't like taking too much risk. They're like, rather buy the startup than actually developing it, taking all the risk. Okay. And so having that in mind, you need investors, yeah? And investors are not just put their money if the next door neighbor can do the same. And that's where patents come in. Big companies too, obviously, because they have competitors, but in the startup world, it's even more acute, because you need that as a cornerstone to put the money and attract investment, and to be sure there's enough protection there to be able to develop. And so yes, you're blocking others, but nobody would do anything if it's in the public domain. Who would take the risk? It's about risk taking. Then you have to remember one thing about patents. So in the law, there are checks and balances, because the purpose of the patents, it's part of a bigger scheme to promote innovation and economic growth. And so I can't get into the whole thing, but there are things like research exemptions, which apply. I can tell you a little bit more on that if you want. So that, and for clinical studies also there are, which relates to research exemptions. But there's also checks and balances in terms of, if you have a dominant patent that's blocking a lot of important improvements, the law promotes cross-licensing. And in fact, it's part of the TRIPS agreement that governments have to have this into their law to allow companies to well, not to block important improvements, if you want, okay, and innovation. And there's other checks and balances in terms of, again, just a pure law in terms of compulsory licensing that governments can step in, if really, in terms of accessibility. Germany has done so, for in certain cases, especially with medicine, usually has to do. And then in terms of competition law, which is not patent law, that's purely economical. There's also here, I mean, a company is dominant and using its patent to block everyone, and it has a very dominant position, or these are other legal tools, if you want to. So that, what I'm trying to say is that there's a lot of checks and balances, but fundamentally, to get back to what I would say, you need a patent to attract investors and actually to be able to develop. It's a long road ahead.
Thank you. That's a very good answer. Very, very practical also on what happens in different scenarios. And I think with this answer already, we've seen some things that people don't immediately think when they think about intellectual property and the various weights that are in place to ensure that the market stays innovative, and that certain inventions don't block completely things like medicines and drugs that could be of national interest. If we could quickly keep going in this direction, pointing at the maybe common misconceptions that there might be in patents in biotech. I'm sure you've had a lot of discussions with other people, probably outside of the field. What would be one myth for each of you that you wish to let's say cancel, like that you want to destroy, that you see it's often there in biotech? And maybe Robert, we can start with you if you can think of something.
I think the misconception that you can't protect something natural that we touched on earlier is like a really common one that I see working with protein engineers, microbial engineers, people who work in DNA technology. I've seen a couple of cases where where people have published their fantastic new strain that that would have been brilliant to commercialize, could have supported great fundraising without patenting it, because they've taken advice from a US attorney who said that they can't patent it, and that's the end of it. So I think, yeah, what we touched on earlier is a big bugbear of mine.
Yeah, I agree. Thank you. And Adam, do you want to say something from your side?
Well, you mean destroy certain practices, you're saying?
Yeah, certain practices, certain misconceptions, certain beliefs that people have when they approach you regarding patents in biotech.
About, I mean, yes, I think what Rob just explained is one of them. There's also, I mean, again, the novelty criteria is, I know it's not just biotech, but there's a lot of misconception that, a publication is the one you put in a big journal and not just, on the internet. There's a lot of misconception on the absolute criteria, and it seems, yeah, it's something that you have to live with every day, and you have to educate. In terms of pure biotech, yes, I mean, again, I think a lot of the researchers are not always well informed on what they can protect, be it from the pure composition of matter, the methods. It's true that in the US, it's the hurdle to protect biotech inventions has become much more complicated. In the old days, you could just take, a biological target, isolate it, and you get a monopoly on that, or you could take a biological target and claim any monoclonal antibodies based on that. You can't do that anymore. The hurdle is very high nowadays in the US, and I had to drop a couple of patents because of that. But there are ways to work around these, even though hurdles are higher. And the same with computer implemented inventions. There's many things you can do, and sometimes people put their own limits. So what I'm saying is probably good to go and speak to a counsel.
Yeah, that's a good advice, I guess. And it's also very good at universities like EPFL, but I'm sure also in the UK that there are many. They have their own offices where researchers can go directly for expert advice. I guess we gave a pretty good introduction to the topic and a general overview of everything. It was very informative. Thank you both. And now I would open the floor for questions from the audience, if there are any. You can either unmute yourself after having raised your hand, or you can write it in the chat and we'll read it out loud for you, for the panelists. So I see that there are no questions yet. Maybe in the meantime, you could clarify one thing that I'm curious about. In academic research, but in general, in some big projects, there are many collaborations. Also in the industry, we see that several companies can collaborate with each other, maybe at different stages of some product production. How does the ownership work in this case? Who owns the intellectual property? Is it something that must be defined upfront before the collaboration starts, or something recoverable later? Any of you could answer the question.
I mean, I can answer if you want.
Yep.
Again, it's a broad answer, but if you want the default, you could actually not set up a contract and just collaborate, which happens all the time between universities, researchers, even sometimes with companies. It happens. They're loose, and then the law applies. And so for patents, it's the ownership follows inventorship. That's generally the rule for most national in most national countries. Of course, then is defining who is the inventor, and defining who is the inventor is not. I wouldn't say it's a uniform criteria, because there are differences between the US and, for instance, Germany, and probably even Switzerland, the UK also. But generally, it's, well, at the end of the day, the inventorship is going to apply where you apply for the patent. That's the rule, okay? With a contract and also the joint ownership regime, everything. So when you don't set up a contract, you take a lot of risk, because obviously you don't know what law is going to apply, etc. So when you set up a patent, you put the conditions that apply. So for company, obviously, most of the time they want a contract. And generally, if they fund the research, of course they'll want certain rights. So these things can be negotiated. If it's a loose collaboration, even there, it's always good to know under what law is applying, etc. But again, you could not have a contract and just go with the law. So for if you had for instance, you had joint ownership in Europe, it's not a very good situation for universities. In most jurisdictions, if you're on a joint ownership regime, again, this is purely patent law. I'm not going to copyright. In terms of pure patent law, a company could use and practice the invention, but it wouldn't be able to license. Universities, we generally license, so obviously it's not a good position. Whereas in the US, if you can't find an agreement, if you're a joint owner of a patent, both by default are free to use and license the invention. So it's much, if you want the freedom to operate is better in the US.
Okay.
So it gives you an idea, if you want, of if you don't set up a contract, what happens? The kind of uncertainty you have to live with.
I see. Yes.
To just drill down into that point of ownership following inventorship. So to determine who an inventor is, you have to determine who the actual deviser of the invention was. So like who came up with the concept. And it's very different from academic papers where you will put someone on your paper because they ran the protein gel and SGS page gel for you and it looked good. The person who invented the invention, it might be the PI, it might be the postdoc, but it's the person who came up with the idea. Who then owns the invention after you've determined who the inventor is, as Adam said, is like as a matter of national law in the UK and I think most European countries. If the inventor is employed by somebody, so if the inventor is employed by a university, their employer, the university, owns the right to apply for a patent to cover that invention. And that's usually a pretty good rule of thumb, absent any contracts. It's very important, therefore, that you get that initial inventorship right, because if you have a collaboration agreement and you have two academics at two different universities, and only one of them came up with the invention, but you want to give the other one inventorship, that flows up to the ownership and can create quite sort of complicated and difficult scenarios sometimes that wouldn't have arisen if you got the inventorship right at the start and excluded the one that ran the STS page gel.
Okay, very interesting. Thank you both. We have a question from the audience. Michael, you can unmute yourself and ask the question.
Yeah, hi. I have a couple of questions, if that's okay. So the first one is, you've talked about patenting sequences and how small changes in sequence can change a patent. I think I was told once upon a time that a patent should also be an instruction for somebody else to use the technology. And so how do you can you talk a little bit about how broad your sequence definition can be, considering that certain combinations of, like if you have variation at certain sites in your sequence to try and cover something that's important in one place, but a combination of those sites might give you, say, a protein that doesn't express properly. And so that particular sequence wouldn't be useful. So how do you go between like spreading a broad enough definition to cover people tweaking a couple of sites to not accidentally including sequences that would be non-functional?
Yeah, I can take this if you like. So all of that comes down to data, essentially. And in Europe, we have this thing called it's a plausibility criteria. So if you have a sequence that you know works, and then you want to claim 10% variation, say, or a sequence that's 90% identical to that sequence, if you've only shown that that single sequence works, a patent examiner will probably say, well, you've not shown that those variants will work. If, however, you do a whole round of mutagenesis experiments and you show that a large or a moderate number of variants which have that 10% variation do work, or they work in roughly the same way as the defined sequence, then it gets more and more likely that the patent examiner will let you have your 10% variation. That then does mean that the patent covers non-working embodiments. But in Europe, at least, that's not necessarily a bar to patentability. And in practice, kind of has no practical application, right? If you're covering something that's a non-working embodiment, it doesn't really matter that if somebody's using that sequence because it doesn't work.
Okay, and my second question was about novelty. If you come up with a new protein, say an enzyme that does a reaction that somebody say has previously patented an enzyme that does that reaction, is it okay if your reaction is equivalent in terms of the quality, the efficiency, the yield, whatever, to the existing one, or does it have to be better than the prior art?
So it depends. Is the answer. And I think it depends on which jurisdiction. So you're kind of talking about using a new enzyme in a known process here. Mm-hmm. Yeah, so that's what we would call, or uncharitable examiners in Europe would call a mere alternative. It's new because nobody's ever used that enzyme in that process. Whether or not it's inventive, in Europe at least, comes down to whether someone would have thought to do it. And you kind of get into very technical arguments with that, with the examiner as to whether someone would have thought to do it. The test in Europe is not could a skilled person have done it, but would they have done it? And that goes to whether there's anything in the prior art that was published before your filing date that suggested the enzyme could work in that process. If there's nothing suggesting that the enzyme could work in that process, no one had ever thought to do it, that's an argument for inventive step. A much stronger one is if there's something in the prior art that says, actually, this enzyme isn't going to work in this process. That's what we call a teach away. And that's a very useful thing to show to a patent examiner to say, look, nobody would ever have thought of doing this. This document even says it wouldn't have worked. I used it in the process and it did work. The surprising effect is that it works. Therefore, it's inventive.
Okay, thank you.
And if it works better than the prior art, then you've got then that's another argument, which I hope it will.
But it's not necessary. Oh, that's
well,
cool.
It's not necessary, but it's highly advised that you have what they call the surprising advantage.
Yeah. Yeah. So, I mean, the answer that I gave was quite European based. I would we would struggle probably to get protection for something that had no kind of beneficial or surprising effect in the US, for example. They're a lot stricter on those kind of things.
Yeah.
Very interesting. Thank you, Michael, for your questions. And as I see we're approaching the 6 p.m. time, I will quickly wanted to ask you a question. And since we are Synthetic Biology Association, of course, we haven't really discussed this specifically, but I was wondering if do you think that the current patent system is well equipped for synthetic biology, or is it lagging behind the science, or if it's really not needed to add any extra step to the current process regarding this? And because of time, I will ask you to keep it simple, also for you, because we don't want to keep you longer than you have already been here.
Do you want to answer, Rob, or shall I?
Oh, you can go first if you like. I realise I've monopolised the last couple of questions.
No, it's fine. It's fine. No, honestly, the patent system is flexible enough and suited, and it won't be changed anyway to cover synthetic biology. Most of the inventions they overlap with things like chemistry. There's nothing new. They're the same issues there. With the Markov structure, the alternatives. Yeah, it's gonna overlap with anything AI and other fields. So all the elements are there if you want. It's not like when the biotechnology emerged or the software in the 80s, 90s. There was like the big panic. How much monopoly should we give, etc. And can we patent this? Is it ethical? So here, I think there's no ethical questions. It's all quite easy and straightforward.
Yeah, I think the one caveat to that is that European and certain other patent systems, they're not very well set up for protecting some genetically engineered plant varieties. And that kind of is a historical tension that comes from plant breeders not wanting to have their plants covered by patent rights. They have their own plant variety rights, which kind of suit traditional breeders very well, but they don't really suit plants made with modern genetic techniques. They don't necessarily suit plants that are being used as expression vectors, and that's something that I think European and UK legislators are grappling with this very moment to figure out where the right line is to try and make that system a bit better.
Yeah, it's true that the other caveat, obviously, I was thinking purely in the European kind of way, but of course in the US and right now, yeah, it's not so easy to always patent for the reasons we gave in terms of the sufficiency. Getting these alternatives, and if you don't have the data and making they don't have the plausibility doctrine. It's a different test, but yeah. So again, the pendulum might swing back. You never know, but it's. So in the US, it's not. In diagnostics too, it's in very difficult for diagnostics at the moment in the US. So there's a lot of pitfalls at the moment in the US with the patent system. Let's say.
Thank you for your answers, and I also imagine it's also very different, of course, if you want to pattern some more molecular thing like a protein or a gene than actually a plant, which is the example that Rob was giving. But yeah, this is a very interesting but a bit of off topic.
Yeah, I think.
So I will give the word to David.
Yeah, I think we are right on time, actually 2 minutes late, and I would like to thank Robert and Adam for their very good discussion. It was super informative. Sorry for having kept you until the very end, but there was a lot to unpack. And I think despite really the great overview over at the very least the importance of the patent field. A good take-home message would be to talk with a professional, given that each single case can be very different from another, and given the importance of the thing, because I don't think somebody would want to patent something trivial. It's important to be sure about what we are doing. So thank you so much. I would like to take this occasion also to thank everybody that participated in the festival, since this is the very last talk of our Protein Engineering and Design Festival. It's been a very good run, starting from the very methods that allow it to happen, going through the applications, the frontiers, and now also the corollary system that allows the innovation process to happen. And with this, I say goodbye to everyone. Thanks so much for joining, both the speakers and the audience.
Thank you, Davide. Bye, everybody.
Bye-bye, everyone.
Bye, guys.
Goodbye.